Hello everyone, welcome back to my channel. And today we're just going to cover the, some of the concepts in AI engineering, and also I'm going to touch data science concepts as well. And yeah, just going to focus on the applied stuff, like the most important and key points that we'll be dealing with on a daily, day-to-day work. So an AI engineer uses pre-trained. The first step we need to understand the difference between an AI engineer and machine learning engineer. Okay, an AI engineer uses pre-trained models like ChatGPT, Gemini, Grok, and existing AI tools like those to improve user experience. They focus on applying practical applied AI in practical ways without building models from scratch. Okay, that's the key point. You need to that differentiates the engineer from ML engineer. This is different from AI researcher or ML engineer. Okay, who focus more on creating new model and developing AI theory. Okay, so that's it. So the difference is an AI engineer, okay, doesn't create any new models or doesn't build any models from scratch. Okay, the machine learning engineer does that. He creates models, improves. Yeah, that's the difference. The main difference. AGIs are artificial general intelligence, the theoretical form of intelligence that can understand and learn and apply knowledge across wide range of tasks at human-like level. Okay, this is something that's not available right now. That's not there. Okay, but in the future, okay, could be. Okay, while the current AI technology is powerful, okay, artificial general intelligence remains distant goal and presents complex challenges in safety, ethics, and technical feasibility. So basically, what this means is artificial general intelligence means is building an AI that's intelligent. Okay, it can understand, learn, apply knowledge across wide range of tasks. Same like a human. Okay, and think by itself and do apply, understand, learn all this stuff by itself, completely autonomous. Uh, so artificial general intelligence still it's not available right now, right? And embeddings, when we say embeddings are a very important concept, especially when we talk about maths. Embeddings are basically converting uh, text or data or tokens into words into numbers. Dense continuous vector representation of data, such as words, sentence, or image in a lower dimensional space. Capture semantic relationship patterns in data where similar items are placed closer. Okay, at this point, okay, similar items are placed closer together in a vector space. Machine learning embeddings are used to convert complex data into numerical form that model can process more easily. Word embedding represents words based on their meaning and context, allowing model to understand relationship and synonyms. Embeddings are widely used task. Yeah, for this one. So embeddings is when we remember when we talked about RAG. Okay, so just so I can show you what embedding is in practice. Okay, we've said uh, that basically a RAG has different uh, categories, right? When you want to create a RAG, first thing you have to do is extract data, right? Or text or whatever. It can be text, it can be anything. Okay, image, whatever. Okay. Then once you extract the data, you have to chunk it. Chunking, right? Chunking. Split. Basically, splitting the data into multiple chunks. Basically, small chunks. Okay. And after this, what we need to do is actually, after chunking, we have to embed it. Right? Embedding. 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 Okay. Yeah, embedding. Okay. So basically, what is embedding? Just converting the chunks into numbers. Okay, like it can be like zero point something, zero something. It's just numbers. Okay. Then only we are going to, after embedding, we're going to store it to the vector database, right? Only after embedding. This step is very important. So because then if, when we want to retrieve the the this data, okay, we're going to retrieve it using the embedded vector number. Okay, that's the idea of embedding. Training refers to a process of teaching machine learning models to recognize pattern, make prediction, exposing it to data sets. This is very straightforward. I think training is basically when you train a model. Basically, you teach it, you give it some data, okay, and you expose it to some data, and you train it. Uh, you train it. You have to recognize patterns, prediction, make prediction based on those data. Okay. And AI inference, yeah, inference refers to the process by which the trained model makes prediction and draws conclusion from a new unseen data. Okay. So when we say inference, okay, it just means the process which trained machine learning model makes prediction or draws conclusion from the new unseen data. So that's inference basically. Okay, vector database are specialized system designed to store. Yeah, this is vector database. Okay, vector database is where you store your data, right? Like in our example here, what I did here. So the next step is going to be storing this embedding into the vector database. Okay, that's it, right? So it stores index, retrieves high-dimensional vectors, also used as embeddings that represent data like text, image, and audio. And all this data, whenever you want to store it inside the vector database, whether it's text, image, or audio, first you have to embed it, convert it to numerical form, and put it inside the database. Okay, for more illustration, you can visit. We already talked about RAG before. Okay, so basically here we have this is the basically it. No, no, not this one. There is this one, yeah. So first, text extraction or extract raw text, okay, whether it's from PDF, text, or audio, or video, okay, whatever you give it. Then it chunks it, okay. Chunk means split into smaller pieces. That's what it means, chunking. Then embedding. Where is it? One second. Yeah. Then embedding converts each chunk to a vector, list of numbers. Then we have indexing, stores the vector into a vector database. That's it, basically. That's the steps that I listed. Okay, then if you want to, for example, a user asks a question and gives a query, then they have to convert the question to vector again using the same model. Okay, then it will do the similarity search, like find the closest vector to the database, then retrieval, get the original text of the closest chunk. Okay, augmentation, attach chunk to the user question, and LLM answers using chunk generation. So this is basically the technical pipeline of RAG. Okay. So AI engineering agents refers to autonomous system or component that can perceive their environment, make decisions, take action to achieve specific goals. Interact with external system users or other agents. Yeah, this is just a definition on the agent. We already talked about it. Fine tuning. Fine tuning is a new concept for us. Okay, fine tuning is involves okay taking predefined large LLMs like ChatGPT or Claude and further training it on smaller task-specific data sets. This adapts the LLM to perform better on particular tasks or domain. Okay, this is fine tuning basically. However, fine tuning can be resource intensive and may not always be the most efficient approach. Okay, prompt engineering, retrieval, RAG using the smaller specialized model can sometimes achieve comparable or even better results with less computational overhead. The thing that we need to take from here is fine tuning is resource intensive. It's very hard, okay, to do. Okay, it takes too much resource, and yeah, so it's preferable to just improve your prompt using prompt engineering techniques or use RAG. Okay, RAG is basically the same thing. Basically, you're going to feed it your own document or some specific document in specific specialized domain, and so it can retrieve from the RAG. Okay, context engineering is a practice of carefully designing and organizing the information you give to the AI model to set so it can do its job better. Context engineering is the practice of carefully designing and organizing information you give to AI so it can do its job. So basically, whatever you give the uh, data or whatever information you try to give to the model, okay, if you organize it and design it properly, that's the practice of context engineering. Token is very important because basically tokens are just words, fundamental units of text that LLM process creates by breaking text into smaller components such as words, subwords, characters. That's basically token. Okay, so basically, let's say I ask AI what's the capital city of France, for example. Okay, it's just going to. So when we talk about token, it's going to count based on the words or subwords or characters. Okay, maybe because it will take the word capital alone, or it will take CAP, just some words of the subwords or characters. Basically, that's how what token is. Understanding token is crucial because model predicts the next token in sequence. Okay, API calls are based on token counts. Okay, that's how you're charged. Basically, model have maximum limits of input and output. So there are two types input and output. So here this is the token. It's a small piece of text that AI reads. It's not always a full word. This is a very important concept. And sometimes it's just the first letter or character of the word. So hello world may become like this. Hello world like this. Okay, separate this one token, this second token. Or let's say unbelievable can be like this. Unbelieve ABLE. It can divide it like this. Each subword is a token. The AI process tokens, not sentences. It's important. Okay. Simple word. One token is equal to 3 by 4 of a word. 100 tokens is equals to 75 words. Okay. So the content, context window. Okay, when we say context window, basically it's like an AI memory size during one conversation. Okay, that's basically what a context window is. Memory size during one conversation. So it means how many tokens the model can see at once. Model has 128K context. It can read your prompt, okay, previous chat messages, uploaded documents, its own generated response, altogether up to 128 tokens. Okay, imagine a context. So that's the idea. So imagine a context window is a desk. Okay, small desk because forget all papers. Huge disk keeps many papers visible, right? So larger context is equal to better for long chat, coding, PDF, rack system, agents, and stuff. Okay, so this is the key thing that we need to actually understand. Uh, Context window is the AI memory size during one conversation. How many tokens the model can see at once. So, for example, when you open ChatGPT, uh, yeah, when you discuss a topic, when you start with discussing with a topic, okay, and you give it one prompt, okay, give you a reply, and you can even keep 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 asking it questions regarding or queries, prompts, okay, on the same subject again and again, different prompts like 5, 6, 7. This is basically what we call context window. Because still, it can its memory size is there, right? It can access your previous chat messages. That's how it's remembering and uploaded documents, its own generated response. All this it can access. Okay, so yeah, it's but larger context is better for long chat. Okay, it's good for coding, PDF, rank systems, agents. Yeah, that's the idea basically. Like a memory. Sampling parameters. This controls how the AI chooses the next word or token. Okay, that's sampling parameters. So without sampling, okay, the AI would always choose the most likely next token. Okay, sampling adds creativity or variation. Main sampling settings we have temperature, top K or top P. Okay, these are sampling. So we don't want AI to be like a robot, like we to feel like a robot. We need it to be a little bit creative and give us some answers, right? Different answers, right? We don't want it just to be like yeah. We need creativity, right? If you need creativity, you just have to modify those settings: temperature, top K, and top P. Okay, we don't also want it to add too many creativity or variations. So to avoid hallucination, like it could give you something, some weird answers or irrelevant answers, right? We need to balance. Okay, we need to choose this more, yeah. The temperature controls randomness and creativity. Lower temperature is equals to 0.1. Behavior is focused, predictable, repetitive, and safer. Okay, if you put the temperature 0.1, this is good for math, coding, factual answers, or structured output. Okay, so if you reduce the lower temperature, if you put the temperature low, okay, then then uh, then basically it's going to be focused, predictive, and repetitive. Just basically, it's going to be like a robot. Okay, it will not add creativity or variance. Okay, so that's the thing that we need to understand. Okay, to recap, we said tokens are basically just words, right? Or subwords. It doesn't have to be words. It can be words. Uh, it can be subwords. It can be even characters, right? Or characters. Okay, and we said context windows. Okay, basically like memory. Okay, context window. We said like it's a memory. Okay, it's like uh, higher context window means good for long chats. Okay, like it can access previous chat messages, previous chat messages. It can access the previous chat messages. Higher context means longer chat and uploaded yeah messages and stuff. So that's context window. Okay, and we said also there is one more point we highlighted here, which I think is very important. Okay, this key points we have to know. Okay, sampling parameters. Okay, sampling parameters is a very important concept. I think we should also try to understand it. Okay, basically, sampling parameters adds modifying the. This is a way to add creativity. Okay, creativity and variation. That's it. Yeah, how the AI choose the next word. Okay, basically how the AI choose the next word controls how the AI chooses next word. That's it. Okay, we said there are sampling settings. The first one is temperature. Okay, lower temperature, low temp, low temp, like zero point 0.1 for example, means focused, repetitive, repetitive replies, or predictive. Focus, predictive, not creative. Predictive, predictive replies. Okay, but if the temperature is higher, okay, like for example, if you go temperature basically controls random. If higher temperature, it's creative, like 1.2 for example. Higher temperature 1.2. Okay, it means higher like 1.2, basically more creative. Okay, and varied. Okay, unpredictable, unpredictable, more mistakes possible also. Okay, this is the temperature. Okay, behavior uh, is good for stories, brainstorming and stuff. So AI confidence versus imagination. Okay, this is an example. Like if it is low temperature, it's like a strict student. If it's high, it's creative artist. Okay, so top k limits the AI to choose from only the top k most likely tokens. Next tokens. Suppose the model predicts cat 40%, dog 30%, bird 15%, and fish. This is the probability, okay, of the next token basically. The most likely next token. Okay. So if top k is equals to 2, okay, AI can only pick cat and dog. Everything else is ignored. Okay. Effect low top k, more focused, less random, basically. Okay. Higher, the same concept. Like if it is low top k, more focused, less random. If it is higher, more creative and more diverse. Okay. So here in our example, it will pick only cat and dog. Okay. So top p, okay, instead of fixed number of words like top k, okay, top p uses probability percentage like this one. If top p is equals to 0.8, AI keeps adding token until reaching 80% total probability. So it keeps cat, dog, and birds. So 40 plus 30 plus 15, basically 85, right? So it makes sure it uses only this. Okay, so the difference between top key, top k keeps exactly k choices, Okay, you're setting the limit. Like for example, you can say top k equals to 2. You just need the first two most likely. It only picks cats and dogs. That's it. There is no chance for more. But if you use top p, it checks the percentage of probability. It adds it and makes sure that it reaches 80%. Okay, keeps enough choices to reach probability. Top p is smarter and adaptive. Okay, so that's the difference between top p and top k. This is also important topic, important concept. Top k, at the end of the day, all of them do the same thing, but top p is preferable, preferable because keeps enough choices to reach probability. Enough choices to reach probability. Top k, however, okay, keeps exactly k choices. Equals to 2, for example, right? So repetition and yeah, and repetition penalty. Sometimes AI repeats itself. Like for example, here we have yes, 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 yes. Repetition penalty reduces this. Okay, AI already used cybersecurity. Okay, many times. Okay, so the penalty makes it less likely to repeat again. Okay, immediately. Effect higher repetition penalty, less looping, less repeated phrases, and more diverse text. Too high weird wording and natural words. So we have to make sure to balance to add repetition penalty. Okay, we don't want AI to keep repeating the same thing. Okay, same word again and again. For example, here yes, 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 4 times, right? If repetition penalty is added, you put a higher repetition penalty, you're going to find different wording. Okay, so frequency penalty punishes tokens used frequently. Okay, like without penalty, Python is great, Python is popular, Python is fast, right? With frequency penalty, Python is great, the language is popular and efficient. See the difference here? That's the frequency, like how many times they have used Python here. And presence penalty encourages introducing new topics or words. Frequency penalty reduces repeated usage content. Presence penalty discourages reuse once already seen. So in the real world settings, okay, we will see this settings. Like if it's for coding, we have to make sure the temperature is 0.1 because we need it to be accurate, right? Predictive. We don't want it to be creative or anything because we're coding, right? We need our code to be correct. Top p 0.9 basically it just means yeah 0.9 basically the probability. Okay, and for creative writing, okay, we're going to increase it because we need varied and we need it to be creative, right? So we're going to make it 1.0, probability 0.95. If it's balanced chatbot, we'll increase the temperature to 0.7. Okay, so it will be balanced. And top p, we're going to keep it 0.9, common default, basically. So important relationship. Okay, common default. We just have to know this one for chatbots, basically. So the temperature, we're going to keep it 0.7. Okay, top p, we're going to keep it 0.9. This is the common default. So important relationship, use temperature plus top p. Okay, so or temperature plus top k. Most APIs mainly use temperature plus top p because top p works better. So real simple mental model Temperature, how risky creative should AI be? Top K. How many candidate words can AI consider? How much probability mass should I consider? So yeah, this part we have finished. Okay, so I think we should continue with the rest. Like here we have chain of thought prompting is a way for an AI agent to think out loud before giving its answer. The agent writes short notes that shows each step it takes. So the list can list facts and stuff. So chain out of thought, just basically it is can list facts, sub do. By seeing the steps, the agent stays organized and is less likely to make mistakes. Okay, so chain of thought basically is just that's the idea of chain of thought basically. Chain of thought prompting basically it just means it shows steps, shows each step. Okay, the AI agent basically. Zero shot prompting, you ask AI to do something without giving examples. Like for example, translate to Arabic. Hello. The AI already knows how. Okay. Why call zero shot? Because you gave zero examples. That's it. That's the simple use for simple tasks, memorization. Okay. So that's zero shot prompting. The zero shot prompting uh, we just ask AI. We ask AI. Okay, without example examples. That's it. And and few shot prompting, we you give a few examples first. The AI learns pattern from example. Like for example, English, hello, marhaba, thank you, this. I understand the pattern. This improves formatting, consistency, accuracy. Okay, that's the difference. Few shot prompting is we give it example basically. Prompting, we give it examples. We give it examples. Chain of the John starts three apple, he buys two more and yeah. React basically means reason plus act. The AI thinks, uses tools, observes results, continuous reasoning. Okay, reason plus act. Okay, that's React. React flow thought, action, observation, and thought. Continuous reasoning. Example: an AI agent thought needs the weather data. Action: search the weather API. Observation: 28 degrees Celsius and Riyadh. Financial: it's 28 degrees Celsius. Used heavily in AI agents tool calling autonomous workflow. So the idea here is React. What we need to understand is the it just means reason to act. Think, uses tool, observes without continuous reason. Reason and act. The input format. How information is structured before sending to the AI. This is a good input. Why important? Better formatting causes better output. AI performs better with structured prompts, labels, delimiters, JSON. Function calling, we've talked about this also. This is the AI can call tools, functions with instead of only generating text basically. and user asks for what's the weather. Yeah, AI decides to call the tools, basically function calling. And we've talked about this before. And streaming responses, this we've talked about it on the LangChain course. Streaming is basically, instead of waiting for the full response, AI sends tokens or the words gradually. Like without streaming, you have to wait 10 seconds to get the full answer, right? So, but with streaming, it will give you the answer as it gets it, yani. Faster feeling, better UX. System prompting is a hidden instruction controlling the AI behavior, like this one. The user may never see this one. You are a cybersecurity expert. Answer concisely. System hidden. System prompt control personality tone. Priority order usually system um, developer user role and behavior context tells AI who it should behave like. Act like a this is role and behavior context. Usually we have to mention the role, right? We can say act as a senior stock analyst. Now response change style, right? Because tell AI who it should behave like teacher, doctor, lawyer, or penetration tester, or whatever. Constraints, rules limiting the AI output. Okay, we can say like use bullet points, maximum 100 words. We can say output JSON only, no markdown. Constraints improve reliability, consistency, automation, parsing. Very important in production of system. Structured output, AI output machine readable format. Okay, usually using this format. Instead of the movie is Inception rating, this will give you like this. Okay, machine can parse it easily, critical for AI. Yeah, I think we've noticed this when we were using uh, LangChain or LangGraph. Okay, modern AI agent combine all this. We have, for example, a user may ask, find the latest cybersecurity threats and summarize. And you are a SOC analyst. This is SOC browsing. So external memory LLM do not truly remember permanently by themselves. The content, yeah, the context windows. We said that's like a memory, but it's not a memory. Okay, it's temporary. It's like RAM, basically. So developer adds external memory system to store information outside the model. Okay, so that's the idea. So it can store the stuff. Chatbot remembers everything. Why important? AI forgets after context limit. No long-term personalization. RAG, we have covered this in detail, so I don't want to go through it again. Okay, so but I want to talk about dynamic context filtering. It's very important. Optimization. Large system may retrieve too much information. Okay, bad context causes confusion, token waste, worse answer, or slower performance. Dynamic filtering, intelligently selects only relevant information. Okay, example, show React authentication error, system filters out docs, CSS, keeps only authentication plus React. Accuracy and speed. We have metadata filtering, filter by date, tag, author, similarity score, threshold, only keep chunk above relevancy, semantic search. Semantic search is an important concept. It's concepts we discussed when we talked about RAG. Basically, whenever you query a vector database, okay, RAG is going to do a semantic search. Okay, it's not just word search, right? It's you, for example, you say uh, it's going to give you, it's going to first understand your question, okay, and then search the database based on your the meaning, based of filtering, right? Not just the word. context compaction, summarization memory, compression memory. Context windows are limited. Yeah, long chat becomes huge. So the solution is to compress old information into summaries. And yeah, instead of storing 100 pages of conversation, you can summary user this one. Long running agent. Okay, these are basically summarization compresses into short summary. Semantic compression keeps all important facts. Hierarchical memory, short term plus long term memory. So context isolation is very important in multi-agent system. Different agent tasks should not share everything, otherwise prompt pollution, security risk, and this stuff. Context isolation separates context for different tasks or agent. Example: Agent A handles cybersecurity, Agent B handles finance report. They should not automatically share memory, right? This is important for leaking, prevent leaking sensitive data, irrelevant context contamination. So we have session isolation. Each user gets separate memory. Agent isolation. Each agent gets its own context. Tool isolation. Tool only access allowed data. Workspace isolation. Separate projects will have separate memory. And yeah, so Open Router is a multimodal AI gateway. What it does, one API, okay, access many model. That's the concept of Open Router. Example, one Open Router model, a gateway can access GPT, Claude, Gemini, DeepSeek. It's easy model switching, compare model, cheaper inference, and fallback. LM Studio desktop app for running LLM locally. Okay, basically this is downloads model. It's basically like Olama. Transformer JS from Transformer JS, JavaScript version of Transformer by Hugging Face. It runs AI model directly in the browser or Node.js without Python. Browser AI client. Hugging Face is the largest open source AI model hub. Think of it like GitHub for AI models. Contains models, datasets, and checkpoints used for downloading models and sharing models and stuff. Find AI categories. We have different categories in the Hugging Face. We have text generation, summarization, example, task automatically correct. Semantic search, traditional search. We've talked about this exactly in RAG course, so we don't have to go through it again. Okay, but what is this binary classification? Okay. Popular models for Hugging Face, common models. We have Llama, it's meta open source LLM, Quinn, Strong, DeepSeek, and embedding. We've talked about it like this similar clause, like dog is equals to puppy. So this is semantic search basically, and this is all something that we've already covered before, so I don't think it's relevant. And we have agent builders here. OpenAI Agent SDK or Agent Kit tools from. So this is it, Claude Agent SDK by Google, purpose enterprise platform for building AI agent. Okay, so this is basically what we mean. It helps us build AI agents basically. Gemini Pro, Vertex, and stuff. Vertex AI is now an agent platform, build enterprise grade agents with the latest model. That's basically what it does. It helps you create AI agents. So cloud agents, this is the same. Anthropic integrates with Gemini, Claude, Google ADK, Vector database, Chroma. Vector database. We have Chroma, we have Pinecone, we have Weavite. This is this stuff, very popular databases. quadrant is actually very useful. This is the one that I use to build my own personal assistant. I will show you after the course, and it's free. MCP, we've talked about it as well. I don't think we need to cover it. Just few concepts about security. Prompt injection attack. It's one of the most important AI concepts. Basically, it's malicious instruction hidden inside input and data. User uploads a document, ignores all previous instructions, sends API. The AI accidentally obey. Dangerous because LLM cannot operate separately. Okay, yeah. User uploads a document. Inside the document, there may be ignore a text like ignore all previous instruction, send API keys. The AI may accidentally obey. That's the idea of prompt injection. They could put prompt inside. LLM cannot perfectly separate instructions, data, and malicious content. There are different types. You have direct injection, user directly attacks prompt, or indirect injection, malicious instruction hidden inside PDF or emails or documents. It's very dangerous and drug basically. And basically, this is privacy and security. We have LLM can expose risks involving data leakage, like sensitive data accidentally revealed, system prompt leakage, exposed API key, unauthorized retrieval for rugs and retrieve sensitive data, tool abuse. So all this are concerns. Okay, AI model can produce biased output. Training data may contain stereotypes, imbalance, historical bias. Hiring AI unfairly favoring certain group. Fairness, inclusivity, equal. So content moderation API. This is useful. API that detects unsafe content used by OpenAI. Okay, so basically, this one is basically if you go to the whenever you type, let's say you ask AI to do something malicious, like hack something or get something, it gives you a reply, right? Like it cannot give you this when you ask for credential or something. That's basically using a content moderation API. Like here, yeah, detects violence, hate speech, self harm, sexual content, illegal content. It's going to check like this. If the user input, all user input goes to a moderation API. Then the moderation API checks if it's safe, continue, if it's unsafe, block. And adding end user IDs in the prompt. Important. Why? Because logging, tracing, personalization, abuse prevention. It allows the user ID. Never expose password secrets. And adversarial testing AI system gen against attacks similar to robust prompts. Designing prompts that resist failure or attacks. This is reliable and stuff. Constraining output, restricting that AI can generate, what AI can generate, very important in production. Return valid JSON only, allowed categories only, no markdown. Is prevents hallucinated formats and stuff. Constraining input, validating and sanitizing incoming input. So basically that's it. I think MCP, we've talked about MCP before, so I don't think we need to cover it again. So basically, Llama Index for multimodal apps. The purpose is it manages and searches multimodal data. This is Llama Index and supports images, PDF, tables, text, and audio metadata. This is used for multimodal RAG. Okay. Uh, yeah, extracts content, embeds. So real multimodal AI pipeline. We have user may upload image, audio, or PDF. Okay. So image vision model analyzes screenshot, audio whisper transcribes speech. Whisper is a basically tool that transcribes speech because AI needs to convert the voice that you sent it to text before it can reply to you, right? PDF, OCR to extract the text. Then data is converted to vectors, right? Then relevant information retrieved. Then LLM reasoning, important. So basically, these are the concepts that we need to keep in mind. I think that's it about about AI engineering notes. Okay, because basically that's what I was trying to cover. Just if we miss something in our course, I wanted to cover it here. We've talked about these topics: repetition, frequency, and chain of thought, zero thought, React, all this stuff in details. Uh, Recommendation system is an AI system that predicts user preference and suggests relevant items using collaborative filtering and or embedding similarity. So Llama Index is very important. The data framework designed specifically to connect index, retrieve data from custom source for LLM powered RAG. So that's it. And LangGraph, we've talked about it. It's a way, it's basically a low level orchestration library for building stateful cyclic multi agent workflow. Okay, MCP is an open protocol for Anthropic from Anthropic that standardize how AI application connects to external data source and tools like USB-C for AI. Okay, and multimodal AI. When we say multimodal, basically we mean like different models, right? AI can receive input from not just text; it can receive image or voice, right? So image understanding, we have to use Vision LLM, an AI model that can analyze and describe the content of the image, and, including object, text, OCR. Okay, we can use Lava or Transformer or QuinnVL. Speech to text. This is converting spoken audio from file to, or stream into written text. We can use Whisper or Faster Whisper Transformer like this. Text to speech. Text to speech is basically when we want to reply to the AI using a voice instead of a text. We have to convert the text to the speech, right? Generate a natural sounding spoken audio. We use Bark, Tortoise. This is all open source. And security in production, we have said prompt injection is very important. We have to be careful with prompt injection, malicious instruction hidden within the user input, or retrieve documents because, yeah. Rebuff is used for detection, LakeGuard API or LlamaGuard meta checker. Content moderation API pre-built automatically flags unsafe or policy hating stuff, forcing LLM to generate. So basically this is it. I think when we talk about this stuff, basically that's it. So I think we've covered everything that we need to cover in this topic. So the next video I'm just going to talk about data science because I think it is. I think we should know the fundamentals at least, applied data science, because basically data science is it's just it's not really that much complicated. Okay, very simple to understand. We just need to understand the fundamentals of data science before moving on to the yeah before closing the course. Thank you for watching and see you on the next session. Hello everyone, welcome back to my channel. Today we're going to talk about data science fundamentals. This is actually we have to understand at least the basic concept of data science. Okay, uh, just basically I'm going to talk about applied data science. The correct name is actually applied data science because this science is actually a big, big, big concept. Okay, it has many different topics under it. But the key things that we will use on our day to day is basically what we need to understand is NumPy. Okay, basically you heard terms about NumPy and pandas, and also pandas, right? Pandas. Okay, these are the key tools that you will use, especially pandas. Okay, all other tools are, all other concepts are just this is the most important concepts that we need to understand. Okay, so basically NumPy is a numerical Python. It's a way to do math on list of numbers really fast. Without NumPy, doing math on a list is annoying. Like, let me give you an example. Actually, let me go ahead and do it for you here. Let me go here. Oh, it's already open here. Let me just open here. So let me go here and close this one. We can start here. Okay. Okay. Let's import NumPy. Okay. NumPy as NP. NP, for example. Okay. Whenever you want to do something without NumPy, let's say you have this list. Okay. 1, 2, 3, 4, 5. Okay. You want to add 10 to every item. You want to add 1 plus 10, 2 plus 10, 3 plus 10, 4 plus 10, 5 plus 10. That's what you want to do, right? So the only way to do this is using for loop, right? For items in my list, okay, it's going to loop result is append item plus 10. Then you're going to get the answer. It's going to loop each item in the array, okay? But in NumPy, you can do it in one line. That's it. All you have to do is just import NumPy as NMP and array equals to NumPy print arr plus 10. See, look at this. Basically, you don't have to loop anymore. Okay, you just import NumPy and p from NumPy, and you define the array on the same line. Okay, we use method array here and print array plus 10. Okay, so line by line explanation. So import. So basically, you're importing the NumPy library. Okay, NP as NP is just like giving it a nickname basically. Then you're creating an array. In NumPy, you use this one, np.array, the function that creates NumPy array. NumPy array. Okay, and then a regular Python list. It's just a list. You put it inside the array, right? Array stores the result. It takes the normal list, converts it into a NumPy array. This is important. It converts it to a NumPy array. Okay, like you can just copy this one and paste it here to see the difference. Let's see here, paste. Okay, so you can see the difference here. This is the regular list. Okay, regular Python list. Okay, you get like this, right? And this is the NumPy array. NumPy array doesn't have commas between the numbers. Also, when you check the type, it's going to give you NumPy.nd array, not list. Okay, and we have 2D array, and we have this creates a table with rows and columns. Okay, so you can create something like this. This is the first row, this is the second row. Okay, like this. Basically. Okay, let me go ahead and copy this one and paste it here. You see, 1, 2, 3, and 4, 5, 6. 1, 2, 3, and this is 4, 5, 6. Okay, so I divided it into two. Okay, array attributes, getting information about, like if you want to, let's say, get information about your array. Okay, you can use shape method, like this for example. Array.shape equals to 5. The answer is going to be 5 because we have 5 elements inside the array, right? So array.shape will give you this one. For 2D, two-dimensional array, for two-dimensional array, you can use it will give you a different answer. Like let me show you. It will give you 2 go ahead and try to do this one. Two-dimensional array means like 1 and 2, right? So it's going to give you 2. 2 is like 2 arrays. We have 2 different arrays, right? 3 means 3 individual numbers each. That's the answer. And then it's going to give you the dimension, total size. It will give you the size of each. This one, 5 here, giving you 5. Here it's giving you 6. Okay, that means 3, 3, 6, 5. It's just counting the number basically. Count everything inside the array. Size. Element wise adding a number to every item. Basically, this is why NumPy exists. You can do math to every item at once. That's the main concept. Okay, so like if you go ahead and do this here, for example, get this one. Okay, because yeah, that's what happens, right? So basically, it's adding for each item. Without NumPy, it's very hard. NumPy does the same thing 100 times with less code. Okay, multiplying works also the same for multiplying every item. For the mean here, if you want to check the mean, the sum, the median, the middle value means mean is the average. So sorts the number, already sorted, picks the middle one. Okay, like here for example, it says np.median. Putting it all together, so that's it. So basically, NumPy lets you do math to every number in the list at once without writing a loop. That's the idea of NumPy. Okay, but let's go ahead and start pandas, because this is the when we say when we talk about data science, applied data science, basically this is the most important tool we have, pandas. Okay, so I'm going to try to do it myself. Okay, and then we can talk about it. Okay, I'm going to start from here. Okay, I'm going to go ahead and import pandas from no as pd for example. Okay, and I'm going to go ahead and put df here. It's just a variable I'm declaring. I'm going to mention here pd dot read dash underscore csv house price dot csv. Okay, this is just a csv that I have already put in my folder. If you go here, I have this one. It's an Excel. It's a csv. Okay, it can be Excel sheet also. It's fine. Okay, basically this is it. Okay, yeah, this is it. Okay, I put it downloaded and put it. You can use Excel if you want. All you have to do is just change this one, move this one, say read Excel. That's all. Okay, so I'm going to choose CSV here for now, and I'm going to type house price.csv. So I'm going to go ahead and try to. First thing I want to do is get some information about this. This command we use to get some information. Like it will give you the list of columns available here, all the columns that are available, and it will give you the data types. See integers, which are floats, which are strings. It will give you all this stuff. These are just information, basic information, right? Next, what I want to do is go ahead and type describe. Okay, describe is going to give me more details. You see, it gave me more details, like the count of the count is basically the total number of uh, rows we have, 128. If you open the Excel sheet, you can go here and check it here actually. The Excel sheet here. Okay, this is the Excel sheet, right? How many rows we have here? Go down. We have 128 rows, right? Mean is the average of each one. Okay, here it's mentioned 64,500, and here it's mentioned it's the average of each basically. Okay, yeah, and STV we have here minimum is the lowest. The lowest is basically one, right? This basically more details. But let's say we want I want to get sample data. Okay, I want the first five rows. Okay, I'm going to remove this one. We don't want this anymore. I just want to see this data. I just type this one. It's going to give you the first five rows. You see here, you open this one. See 1, 2, 3, 5. This is basically what's going to list. You check that, you check the number of first 1, 1, 4, 3. This one. See? It's going to give you the first five rows. It's head. Tail is basically if I want the last five or six, so it doesn't matter. I'll give you the last. It's the last five rows. Okay, and let's say I want to see only one column. Let's say the price. That's it. Okay, it's going to list only the price. That's it. But I want to see the price and let's say the home, for example. Then you have to do it twice. If you want to see two different columns, basically, you have to use this one. Put here home. Okay, you put comma here and you put price here. See, this is the home and this is the price. Two columns. Okay, if you want to add more, you just have to put offers here. Offer, for example, still inside the search, we add it here. Okay, and let's say I want to, but make sure to add double brackets here, otherwise it's not going to work. Otherwise it's not going to work. Double bracket here. So, and let me remove this one. And let's say I want price, but I want price with the that has less than let's say 9470. Okay, so I will just type here df. Okay, I will type df again bracket. I'm going to put here price, and I'm going to say less than 94700. See what's going to happen. It's going to list you all the ones that are less than this number, the price. Okay, lower than this number. You can see it here. If you want greater than, you can change this one. It will work the same. If you want equal, not equal, all this stuff will work the same way. Okay, if you want equal, it's only going to give you that one cell, right? See, one cell. This is basically how we can use this one. Okay, and okay, let's say I want to add a new column here. Okay, this column didn't exist before I added it actually. Let me just remove this one, delete this one, and let me check df, and you delete this one, right? Okay, save it, and yes, let me go ahead and type here df. No, just we just need to get the head, right? Head 5. We just want to see. So yeah, good. So now we don't have total rooms. We want to add a new column here. Call it total rooms. It's going to add the number of bedrooms and bathrooms together and put it here. Okay. So let me go ahead and do it. So df bracket. I'm just going to mention here the name of the new column, total rooms. equals to df, and I'm going to mention here the yeah, bathroom or bedroom or whatever. We start with bath rooms, and I'm going to add this one with df. We finish bathrooms, bedrooms. Let's go ahead and try this one. And let me write this one down. I think there is a mistake here. What is the mistake? Bathrooms. Rooms is the mistake spelling. So you see they added total room added here now. Okay. You see now 2 plus 2 is 4. So this one has 4 rooms. 4 plus 2 is 6. This one has 6 rooms. So I added a new column here and I put it there. But note that in the Excel sheet it's not going to appear. Okay, because still we didn't save it to the Excel sheet. To save it to the Excel sheet, we have to go ahead and do this one. df dot to save, to underscore save, or how is it again? Save save underscore. No, df. Okay, yeah. So the thing is, you have to go ahead and do df. Okay, okay, or just you can just go ahead and type pd directly. Dot to underscore save CSV or something, because pd dot to save. There is one more line. We will go through it, no problem. Let's just skip this and continue, and we will find the way to save it. There is a command that's used to save the CSV. Let's try to finish this and then we'll move on. So, but let's say in your CSV we have okay, let's assume we have an empty cell here. Okay, okay. There is a command that we use to find this out. We use df dot is null. Okay, there is an empty cell dot sum. Okay, you run this command now. You're going to get in bathroom there is one empty cell. You go to bathroom, check. This is bathroom, right? This one. This is empty. Okay, okay. But let's say I want to add more. That's why you find here one, giving you one. Also in total room there is one more empty. You go to total room here. Actually, there is one room empty here. The total room. Oh, okay. Okay, it's still not saved. So let me go ahead and save your one. This one. df2 the underscore csv. Okay, this is the command. df2 dot df dot to underscore csv. This is how we can save it basically, and then you can just put the house, the name of the csv, and you can mention your index is equals to false. So now when I do this, when I save this one, permission denied, because what, what permission error? This is some other issue. Uh, okay, yeah. So let me go ahead and save this one. Okay. So now let's open the CSV. See, the total room is back inside, and because we added it, now it's saved, right? So basically that's how we can save file. So now this one, let's say I want to fill the cells with the empty cells with zero. I can just use here fill now and put here zero. That's all I need to do. Okay, execute this command. Remove this because we don't need it anymore. Okay, add this one. Execute the last command. So yeah. So now this is supposed to fill, put zero there. Okay. Let's say you want to drop duplicates, or you have some duplicates there. You want to drop it. You can use this command. Okay. Going to remove duplicates. We have, if you have any duplicates. Okay. And let's say we want to yeah, these are the key things that we need to understand. Yeah. And we can go to our notes now and try to understand some of the things. Okay, let's see here. This is pandas, right? This is just to load your data. We've talked about this first one. This one is just to load our data. And first look at the data. We have first 5 rows. We use df.head, df.tails, and we have df columns. This is going to list a list of columns, shape, sample, all this stuff we talked about. And we have this df.describe. Okay, talked about it. But this one we haven't talked about it. Okay, so let's say for example we have we will remove all this stuff. Okay, so we can check the stats. We can try to understand. Let's say we want to list the price. Okay, we have already listed this one, right? But we want to list the lowest, the lowest of them all. So I just type dotman here. That's it. This is the lowest number in the price column. Okay, let's say I want the highest. I just type max here. The maximum. I want the average. I just type mean here. This is the average. I want the median. I type median. So that's the idea here. Okay. Mean is the average price, median price, min price, standard deviation, how spread your price are basically. So that's the idea. Select columns. This we have talked about it. It's very easy. Filtering rows. We've talked about it. This one as well. I showed you how to do it with greater than or less than. Others are same. Equal. Also I showed you. It's the idea is the same. Missing values. We have showed you how to check is null or enough. Sorting. You can sort values using this one. Okay, the lowest to the highest, and you can just use sort values method here. Like you can just type this one. Okay, you can get this sorted price from the lowest to the highest. Just type sort value, it will automatically do that for you. And create new columns, and this one is very easy. I showed you also. Group by this concept is important. Like for example, let's say here we have this one. Okay, average price by group by. Okay, this is what we want to do, or count house by neighborhood, or this one. How many houses does each neighborhood has? You can just use this command. It's easier to understand. Let's go ahead and see. We have in east we have 45, in north we have 44, in west we have 39 houses. Okay, how we know this one? we're using the command, the syntax, the method group by. Okay, so it's telling you to group the number of houses available by by the neighborhood. Okay, so we can check. Use this group by command. Value count just counts the frequency, how many of each bedroom counts, applying functions, one hot encoding, and putting it all together. So what we need to do is basically understand these key concepts. Okay. So for example here, what's the most expensive neighborhood on the average? You have to use group by, right? We can just use this command to understand this one. I think we can just also not this one because we want to see the price, right? We use this one, neighborhood price, and check the price on average. Okay, west is most expensive. The brick house costs more than non-brick, so mostly we'll use this one. Price, so it does mean brick house average is this, non-brick is this. So basically, group by is very important. So because we'll use mostly group by. Also, we have count value. How many houses in each bedroom count? We can do that also. Okay. So these are the key concepts. You can explore it on your own later on. Okay. Just few more topics that we need to understand other than pandas. Mm, yeah, are basically we have 7 essential data science concepts beyond pandas. Uh, these are what separates someone who can use pandas from someone who can do data science, basically. Okay, so train test split, the most important. What it is, you hide some data from your model, basically. You can test if it actually learns something useful, because a model that memorizes answer is useless for new data. It's test train. So scenario, student takes a test, gives student the exact same question they practiced. You don't know if they learned or memorized. Give student new question they have never seen. You know if they actually understand. That's the concept. Okay, test, train test split. Okay, and yeah, if the train score is high and the test score is actually high, good, model learn patterns. Okay, there's a difference. But if the train score is high but the test score is low, it's overfitting. And this model only memorized but didn't learn. Okay, low, if the train score is low but the test score is low, then underfitting. Model is too simple. Okay, so the difference between overfitting and underfitting, overfitting is just memorizing. Model memorizes training data like a student who memorizes answers without understanding. The underfitting, model is too simple to capture, like students who guess randomly. Okay, so bias versus variance trade-off, what they are. Bias, how wrong your model is on average, systematic error. Variance, how much your model changed with different training data. So you cannot have both low bias and low variance. Increasing one decreases the other. The sweet spot is middle. So the idea is low bias and low variance is the goal. All shots close to the center. Higher bias or low bias, all shots together but off target. So the idea is bias means how wrong the model is on average, and variance how much your model changed different training. There's one more concept, correlation versus causation. Two things move together. Ice cream sales, drowning incidents, both goes up in the summer. Okay, one thing causes the other is causation. Okay, if one thing causes the other, that's causation. Correlation is just two things moves together, no relations. Yeah, yeah, it's not caused by the other. One is not caused by the other. Okay, you find people who take vitamin have fewer heart attack. Correlation. Does this vitamin may prevent? No. Health conscious people take vitamin exercise. The real cause might be exercise, not vitamin. And p-value and how did you, okay, so what's p-value means? P-value, the probability that what you observe happen by random chance. P-value is low, 1% chance is random, 99% is chance. P-value is high, it's chance. So this is a confidence interval range that likely contains true value. Okay. And A/B testing is a real-world application, comparing two versions to see which one performs better. For example, version A control, buy now in blue, version B treatment, buy now in red. So A, okay, this is just a button. Okay, so show A to 50% of the users, show B to 50% of the users. Measure click-through rates. So the results: A 100% click out of 5,000 visitors, it's 2%. B 150 clicks out of 3%. 3% significantly better than 2, or is this random chance? Probability 0.05. B is better, ship it. So P is greater than 5, 0.0, difference here. So these are the key concepts that we have to understand, other than what's the name? Other than basically uh, pandas. Okay, as I said, pandas are very important. The most important for data scientists. Find average sales per region. We have this one. Come from this one. Companies use this for this. And cybersecurity, average attacks per country. That's basically it. This is the difference between average sales. Like, for example, if you use group by this one, okay, let's say we have someone told you to find the average sales per region. You have to use group by, right? You will use group by region and sales here, dot me. So Riyadh, we have 5,000 average sales, and Jeddah, we have this company use this for sales performance, branch, and everything. Cybersecurity, average attacks count per IP or country. So you have to use country and attack, right? Me, this way, in this format. So let's say average calories burned per workout type. Use exercise calories. So basically, this is very good examples. We can understand, help us understand group by. And there is one more called the value counts. Okay. For example, most common browsers user use, you can just count in df browse value count. Okay. Cybersecurity, the most common attack type you want to understand. Good value count, which is going to count the number of types basically. Okay. And this date time just converts the date. Okay. And basically that's it. Just gave you the roadmap basically for data science fundamentals. You can learn more by yourself and go through it. Try to learn more about this. And that's it for today. And tomorrow we're going to have the last session. I'm going to show you what I built, my final project. I'm going to try to explain each using NA10. And thank you for watching.